So what I'd like to do is for each column or each row of this matrix, I'm looking at the distance of every other observation to a single observation. So if I look across row one, for example, how can I identify which observations are closest to it? I can reorder all of these observations. So there is a function called order, which orders the values of a numeric um, vector. So here's a numeric vector. It's got four values, 5, 1, 2, 4. Let's say I want to reorder them so from largest to smallest or smallest to largest in some way like that. And run this code cell. And so what this tells me is the smallest value is located in position 2. The second smallest value is located in position 3. The third largest value is located in position 4, and the largest value is located, excuse me, that was position, yeah, is located in position 1. So it's telling me this is the smallest value 2. This is the second smallest value in position 3. This was the third smallest value in position 4. And this was the largest value, which was in position 1. So this is telling me how to, which element is the smallest in that list, which element is the second smallest, and so on. So if I do something like order D1 comma space, D1 comma space, when I index like that, this is indexing the first row of matrix D. So I'm looking at all of this. And then when I run the order command on that, it's going to tell me in which column is the smallest value. So in other words, it's going to tell me which observation is closest to it. And then it's going to tell me which column is the second smallest value. And that column number is going to correspond to the next observation closest to it. So if I run this code cell over here, this is reordering that row. So it's telling me the smallest value in that row is located in position 1. That's right here. The second smallest value is located in position 2 over here. So this is telling me that flower 1 and flower 2 have the same exact dimensions actually. And now it's telling me that the third closest is 5 and the fourth closest is 9, and so on. And the furthest observation is 119. So this is telling me which observations are closest to it and which are furthest to it in order. So now I can see exactly how close all of the other observations are to observation 1. Similarly, running this code cell is going to order how close are observations to the second flower, how close are observations to the third flower. So what I can do is take output like this, for example, and store it to something that I call OD1 for the order of things relating to the first observation. So that would store this entire vector. And now what I want to do is I don't want to pick off 1, 2, and 3, the first 3 observations in this vector, because that includes itself. So I don't want to include the observation itself in indicating that it's one of the 3 closest things. So it's assumed that we're not going to include itself, but we want to find 3 other observations that are close to it. So that would be the number indicated in position 2, position 3, and position 4 of this vector. So that's what this is doing. This is pulling off. It's going to ignore the first entry because the first entry is itself. And instead, it's going to pick off items 2, 3, and 4. And this is telling me right here that the closest thing to the first flower is flower 2, the second closest is flower 5, and the third closest is flower 9. So now we can finally write a for loop that's going to do all of this for us. So what I want to do is run this loop from 1 up to 150, since I'm going to have 150 things in my list. So how I calculated 150 was I indicated the length of this list where we're going to store all of this information. And that list had a length that was given by the number of observations in Iris Petal. So I've got my for loop. It's going to go from 1 up to 150. It's going to do this 150 times because that's how many observations I had in my data set. For each value I, it's going to go into that matrix D, the distance matrix, pull off row I. It's going to reorder all of the values in I from smallest to largest. And then it's going to tell me, so that's what happens here. So this is like an ordered list of distances for the ith observation. And then this is going to pull off entry elements 2, 3, and 4 in this ordered vector. And the reason why we go 2, 3, and 4 is we ignore the first one because the first one is going to identify that the closest observation is itself. So we're going to store this vector. This is going to be a vector of 3 values like 2, 5, 9. We're going to store that in entry NNI. We're going to call this NNI for now. And then this is what we're going to store in the ith position of the list that we called NN list. And I want to put this inside of double brackets because here we've got a vector and we want to put this vector inside of the list and store it inside of that list. So I'm going to run this code cell. I did not run this up here. I don't think I ever created this list. Sorry. So now I've created that list. You want to make sure you run that code cell first. That's like our container for where we're going to store all of this information. Now I can run this for loop. It did all of that really quickly. We don't see any output because we didn't ask for anything to be displayed on the screen. But if I look at the first 3 elements in this list, it's going to list the nearest neighbors for flower 1, flower 2, and flower 3. So this is telling me that observation 1, its nearest neighbors are 2, 5, and 9. I'll skip 2 for a second, but observation 3, the nearest neighbors to that are observation 37, 39, and 43. And the second entry is telling me that observation 2, its closest neighbors are 2, 5, and 9. But we should not identify a nearest neighbor as an element itself. And here I'm getting this error because there's this special feature of the data that our first 2 elements in the petal iris data set are identical. They have the same dimensions. So what I would really want to do down here is not identify that the nearest neighbors are of element 2 are 2, 5, and 9, but that's kind of a special case here where it was equal to the dimensions of another observation. So what I actually would want to indicate here is that its nearest neighbors are 1, 5, and 9. So there's this little issue that popped up, and we'll think about how we can address that more comprehensively in the next video.